Okay, we're going to talk about graphing linear non-proportional relationships and using slope and y-intercept to do that. So let's kind of go through what those words mean so they don't seem so awe-inspiring here. Graphing is basically we're going to look at we're going to put points on a coordinate plane. Linear means it's a line. So basically we're going to graph a line. A non-proportional relationship is a line that does not go through the origin. In other words, we're going to have a y-intercept. And what we're going to do is learn how to graph using that slope and y-intercept as opposed to making a table of values. So our essential question of how can you graph a line using the slope and y-intercept hopefully should become very clear after the first example. So here we have an equation y equals 3x plus 2. What we need to do is define what the slope is and what the y-intercept is. We know the slope is located right here next to the x, so that would be 3, and the y-intercept would be 2. I'm going to put down words next to these letters because I think it'll have a little bit more meaning for some of you. And what we're going to do again is how do we graph with this? Well, we know that between the two, slope and y-intercept is the one that is a point, and it's located where the graph crosses the y-axis. So we're going to go to positive 2, and we're going to put a point right there because that actually is a point. Now slope is the direction of a line or the steepness of a line, and we can determine that by rise over run. So if we take the number 3 and put it into a fraction 3 over 1, we'll see that we can get a rise of 3 and a run from 1 from this point of the y-intercept. So we'll rise 3, 1, 2, 3, and over 1. We can do that again, rise 3, 1, 2, 3, over 1. We can see that we're getting numbers in a line. So what I'm going to do is grab a line here, and grab a line and go through these points. Now you'll notice that when I draw a line, I make sure that I'm going as straight as I can. I also want to make sure I'm extending through the points, and I want to put arrows at the end of them because the line will go on forever. We're just seeing a small snapshot of it. Now let's talk about this a little bit, and I'm going to give you my interpretation of what the letters M and B could represent to help us how to graph. I look at the y-intercept because it's a point. This is where we're going to begin. Where we begin on the graph. We're going to begin right there at 2. Slope is going to represent how we move. So how we begin, how we move. And how we moved from there is we went up 3 squares and over 1. Again, we went up 3 squares and over 1. So that should help us to learn to graph. Now, some things to think about. We have a positive graph here because this is positive 3 over 1. What if it was negative 3? Well, again, the rise will take into account whether we're going up or down. If it's positive, we're going to go up. If it's negative, we're going to go down. And you'll notice that the run is always positive. So we're going to take the run always to the right. So up and to the right or down and to the right. And that way we can get the correct slope on our graph. Let's try it again here in example number 2. We're looking at y equals negative 3/4 x minus 2. Let's find the slope and the y-intercept. Again, here we take a slope. It's a number next to the x is negative 3 over 4. And the y-intercept is 2. Slope, y-intercept. Again, we're going to graph these points. This is where I'm going to begin. I'm going to begin at negative 2 because that's the only one that actually is a point. And then I'm going to have a slope of negative 3 over 4. So I'm going to go down 3, 1, 2, 3, and over 4, 1, 2, 3, 4. That's how I'm going to move, right? Okay, so now I have a line. And really, you only need 2 points to draw a line. You don't need any more than that. And you want to extend your line all the way through your points and make sure that you have arrows on the end of them. And then you can see there's our line. Now you need to think about this as far as when it comes time to points on a line and what means what. So I'm going to talk about this point right here for a second. Okay, if I was to figure out what this point is, this is somewhere between maybe 1 3/4 or maybe 1 7/8, and then down 1, 2, and I don't know, maybe 1/8, negative 2 and 1/8. So when we're looking at points that are on this line, there could include fractions. So that's why it represents the millions and millions of possibilities on a line. That's why we draw a line through it. Unless we're talking about something in the real world, then we're going to look at it a little bit differently. So I have a real world example here for us. And if we take a look at what's going on, here I have 2 companies, the red dot company and the green dot company. And I'm taking a look at buying headphones. So we notice that on the x-axis of the graph, we have number of headphones. On the Y, we have the dollars, or how much headphones are going to cost. So in order to analyze our data, we're going to find out what the slope represents first. So when we make slope, that means we're going to take a look at these red dots. And I'm going to pick any two red dots. It doesn't matter which two I'm going to pick. And I'm going to make a triangle from those red dots. Now again, the reason that there are dots and they are not lines is because in the real world, is it possible to buy half a headphone or 3/4 of a headphone? It isn't. So that's why there's no line extending through. I can buy 1 headphones, 2 headphones, 3 headphones. There's no line. So that's why we're lacking in the line there and having only dots. If we count our rise and run boxes, we notice that we have 4/4. Now you may have drawn a different size box, but either way it's going to reduce down to 1/1. But we need to know, what does that mean? Well, that means that a rise of $1 means that I can buy 1 pair of headphones. So for the red dot company, they're going to cost me $1 per set of headphones. Now we do have a y-intercept here, and the y-intercept is at $5. Well, what does that $5 represent? Because I notice that when I'm buying 1 set of headphones, it's costing me $6, not this $1 per. So we can maybe attest it to shipping. So we'll say that we had $5 in shipping plus 1 pair of headphones gets me what I need from the red dot company. Let's talk about the green dot company, which is these small little skinnier dots here. And we're going to do the same thing. We're going to find the slope of the line. So again, I'm just going to pick 2 dots and draw a triangle. And I'm going to count my boxes. So here I have 4 divided by 2, rise over run, and that reduces down to 2/1, which again, we have to put it in terms of the problem, is $2 for 1 pair of headphones. And the idea of pair, maybe using the word set might be a little bit better, so let me change that. Instead of pair, people think 2, so we'll say 1 set of headphones, 1 set of headphones for both. Okay, and again for the green dots, it has the same thing where it's $5 for shipping. Now if I was going to do a quick little comparison of these two companies, I noticed that the green dot company is more expensive. Even though they started at the same place at $5 for shipping, they have the same amount for shipping, but cost per set of headphones is going to set me off. And you'll notice that the line is a lot steeper of the green dot company. So one thing we know is that as the steeper the line gets, the more expensive things become. So I'm probably not going to be buying from the green dot company. But let's try and put some of that information into an equation. So for the red dot company, let's write an equation. Would be y equals 1x plus 5, because a slope of 1 and a y-intercept of 5. The same thing would be true for the green dot company. Y equals 2x plus 5. Now, looking at that, let's try and throw a curve into this, and let's get a third company involved. What does this equation tell us about buying a different opportunity to buy headphones? Well, we notice that there's no number floating out there. So what that tells us is that, hey, there's free shipping. I'm not going to pay for shipping if I buy from the equation company. Also, I get to find out by the slope. We know that that's 2/1. So that means that each set of headphones is going to cost $2. So now we have some more information so that we can compare. So let's put all the information in a table so we can decide which is a better deal. And what does it really depend on? Well, I think we kind of notice it really depends on how many we choose to buy. So let's make a chart to do that. If we stay with the red dot company, which we said our equation was 1x plus 5, let's substitute these values in for x and find out what the y would end up being. So if I buy 1 set of headphones, 1 times 1 is 1 plus 5 is 6. If I buy 2 sets of headphones, 1 times 2 is 2 plus 5 is 7. I buy 3 sets of headphones, 3 times 1 is 3 plus 5 is 8. We notice that they're going up by 1. So we can finish the table, 9, 10, 11, and 12. And it will keep on going. We're going to stop at 7 headphones. Now let's take a look at the green dot company, which we said was y equals 2x plus 5. And let's do the same thing. 1 set of headphones in green dot would be 2 times 1 is 2 plus 5 is 7. If I bought 2 sets of headphones, 2 times 2 is 4. 4 plus 5 is 9. If I bought 3 sets of headphones, 3 times 2 is 6, plus 5 is 11. We notice that it's climbing by 2s each time. So we're going to finish out the table here as well. 13, 15, 17, and 19. Now the last one, the equation company, y equals 2x. And let's figure that out. If I buy one set of headphones, 2 times 1 is 2. 2 sets of headphones, 2 times 2 is 4. 3 sets of headphones, 2 times 2 is 6. 2 times 3 is 6, excuse me. And we'll notice that it changes. 2, 4, 6. It's going by 2. So we're going to finish the table here as well. So now that we have all our data in a table, we're going to figure out what the best deal would be in which situation. So let's take a look. If I was only going to buy one set of headphones, I would purchase it from the equation company because it would only cost me $2. Now, before we continue this, a lot of people say to me, well, what if it's the type of headphones they are? What if it's the quality? We're going to assume that all these headphones are the exact same quality. You've been to the mall before where you've seen a pair of jeans offered in 3 different stores, the exact same pair offered at 3 different prices. This is kind of the same analogy. So if we're going to get 2 sets of headphones, equation has the better deal, that it only costs me $4. Again, at 3 headphones, I'm still buying from equation, as well as 4 sets of headphones I'm buying from the equation company. Now, when I get to 5 sets of headphones, now I have choices. I can either buy from equation company or I can buy from the red dot company. Now, at this point, it's going to be preference. Maybe the red dot company is going to get it to me faster, even though I'm paying for shipping, and I'm not paying for shipping the equation. I might get it faster than I am from equation. So that might play a part in my decision between red dot and equation. Now at 6 headphones, red dot seems to have a better buy at 11. And at 7 headphones, again, red dot's better at 12. So let's write down about each company when it's good to buy from them. Let's start from the green dot company. And we kind of said this from the beginning. They're just the most expensive option no matter what. So we're probably not buying anything from them. The equation company looks pretty good as long as we want to buy 5 or less. As long as we buy 5 or less, then we're going to probably buy from the equation company. It kind of ties with red dot company at 5, so that's going to be a personal decision. And then the red dot company is always cheaper than the green dots, but better than the equation if you buy 6 or more. And if you go out into the real world as a purchasing agent, you're doing this type of comparisons at least 6 times a day. Different companies, kind of seeing what's going on and applying that. That's where the math is in the real world here. Now, let's kind of take a look at something else. This is a little bit more along the line of physics, and it's called Hooke's law. And Hooke's law is that the stress within a plastic solid up to the elastic limit is proportional to the strain responsible for it. Now, I know that's kind of a lot of information. So what I want to do instead is show you guys a video. Now in this video, it's showing us just stretching a spring, and each mass that he keeps adding to it is going to be 100 grams. You'll see that he starts with a certain spring, and then he starts adding, and he's checking out and keeping track of how much weight is being added. Now this is going to continue on for quite a while. I'm going to kind of jump to the end here just so you can kind of get the idea of what's about to happen. And again, if we were studying Hooke's law, this is probably a good thing for us to look at. But since we're not, we're just going to kind of use it for the data. I like the idea of the data, and that's why I wanted to share it with you. And look what happened to the spring. Not only did it elongate, it got a little wider and things like that. So now let's apply it back to what we were doing. So how long was the spring when the experiment started? That's what we're going to figure out because we didn't really get that information from the video. So here's the table of what was happening. And what we're going to do is we're going to use our equation y equals mx plus b and find out what is that, where did it start, what is that initial point. And for us, an initial point in the real world is the y-intercept because everything in the real world occurs in the first quadrant. So in order to do this, we need to we can take a point, which here there's a great point right here in the middle with no decimal. So we'll kind of use that where weight in mass is x and the measurement is y. So now we've got to figure out also now the slope, which is the change in the y and the change in the x. So let's figure that out here. We notice that this changes by 100. So we're going to use that as our change in x. And let's get an approximate change here. So this is changing by approximately 4 each time. Okay, so we're going to say that this is going to change approximately 4 millimeters for every 100 grams added. And if we reduce that, that would take us down to 1/25th. And that's going to represent our slope. So what we're going to do now is we're going to take all this different piece of information. That's going to be the x. 55 is our y. Our slope is going to go here. And what we're going to do is we're going to substitute this information into the equation and solve for it. So we're going to put 55 equals 1/25th times 600 plus b. And we're going to try and figure out what b is. What is that initial spring length? Now, some people might be overwhelmed by 1/25th of 600, but if we think of 25 in terms of quarters, we know there's 4 quarters in $1, so in $6 there's 24. So this whole thing reduces down to 24. So let's write a cleaner equation. 55 equals 24 plus b. We need to figure out what are we going to add to 24 to get 55. The way we do that is we subtract 24 from 55 and we get 31. So now that we know that 31 is the y-intercept, so with this information, not only did we find out where was the spring the experiment started, it started at 31 millimeters, we can also now write an equation of the line y equals 1/25th x plus 31. And we can then find out at various weight mass grams that we're adding, how far is it going to stretch out. Now, what we're going to do is practice plotting, because remember, this section is called graphing linear non-proportional relationships. So let's kind of plot what we just saw. We're going to start at 31, and here we have a real world scenario, so we're going to see a squiggly line. We're not going to show all the way up to 30, but each of these goes up by 2's. So 31 is going to place us right about there. Now, I could do 1/25th, but these things are going by 100, so I'm going to kind of change it so I can go by 100 on the x-axis, right? Because this is x and this is y. And if I change that, that'd be 4 times. And again, we're back to that 4 per 100. So 100 will move me all the way over, but I need to add 4 to 31, so that'll take me to 35 and put me right there. If I add 4 to 35, that'll put me at 39, and that'll put me there. So I've got at least 3 points. So now I'm going to draw a line, and I have to remember when I draw a line in the real world, I am not going to be starting with an arrow on both ends. I'm going to only have an arrow on one end and go on and on and on. And the reason for this is because in the real world, you're going to stay in that first quadrant. You're not going to go anywhere else. You don't want to go out here because we can't have negative weights, negative measurements. So this is kind of how it's applied about being able to graph linear non-proportional relationships using slope and y-intercept. And hopefully you've learned a lot about doing that by watching this lecture.